Our lesson for today will be looking at Physics 1505. The topic for today will be looking at vertical projection. Practice question lesson 101. Let us start. We know that whenever we have practice lesson videos, that is when we look at one of the questions to apply what we have learned. By the way, we do have lesson series of the entire lesson whereby we explain in detail. We explain this chapter, which is a vertical projectile. You can also get it from the playlist of grade 12 physics. You will find the entire lesson series there. So our question for today is this one. Without wasting time, let us start with the scenario. The scenario says a rock is dropped from the top of a vertical cliff and takes 3.00 seconds to reach the ground below the cliff. So I normally want us to draw a picture form of the scenario. So let's say this is the cliff and we have a ball which is dropped. One of the very important keywords is this one. It was dropped. So initially, let's say it was here, and then it was dropped, and then it is here. And then we know that the moment we see the word dropped, it means that it was not projected. So the velocity which it was dropped will be 0 meters per second. And then we can see that from, let's say this is point A to B. From point A to B, it takes 3.00 seconds for this ball to reach the ground, which is point B. And then we know that from point A to point B, it experiences the gravitational acceleration of 9.8 meters per second squared. Let us take down as positive, up as negative. Remember that we are dealing with a vector. This is a vector, so direction is very important. And then when you continue, a second rock is thrown vertically from the cliff, and it takes this rock 2.00 seconds to reach the ground below the cliff from the time it is released. So we can say this is ball 1, this is ball 1, and then for ball 2, let us represent it this side. So ball 2, it was thrown, it was projected, it was not released, and then it reaches the ground. So we say this is ball 2, and then from the velocity here, it cannot be 0. We don't know the velocity. It was thrown with a certain velocity. And then also we don't know the velocity at point B. This will be point A, this will be point B. And then we have our time from point A to B, which is 2.00 seconds. And then we know that G is 9.8 meters per second squared. This is what we actually have. Now the question is, with what velocity was the second rock thrown, assuming no air resistance? So we are looking for this velocity here of the rock. The second rock, by the way. Now with the first rock, what we can do, we can perform calculations so that we can be able to answer the question of the second rock. Now let us go back to the second rock, which is rock 2. What do we have? We can take out all the equations which has time, acceleration, and initial velocity, or the final velocity. So the first equation that we can possibly use is this one. It's V, it's equals to Vi, which is V initial, plus AT. In this case, this V will be the V from position B of the second rock equals to V initial, which is the one that we're looking for at point A, and then we do have the acceleration, we do have the time, but we don't have the velocity at B. So it is challenging for us to use this equation. Let us look at this one. V squared is equals to Vi squared plus 2A, and then we have our displacement, we can say S. The velocity at B, we still don't have it. We are looking for the velocity at A. We have the acceleration, but we do not have, actually have the acceleration, but we do not have the displacement. So either way, even if we had the final velocity at B, we still won't be able to calculate this because we're looking for the initial velocity. But we have the two unknowns, which is the final velocity and the displacement. Now we also have this S is equals to the initial time plus half A time squared. Looking at this equation, we do not have the displacement. We are looking for the initial velocity. We have the time, and we also have the acceleration. With this equation, we can see that we are looking for the initial velocity. We do not have the displacement. We also do not have the final velocity. But with this equation, we can calculate this. This equation, we actually have three unknowns. We have the final velocity as an unknown. We have initial velocity as the unknown, but we are looking for that. We have the displacement as the unknown. But with this equation, we only have the displacement as the unknown. But looking at the scenario, if you can check, since both of these rocks, they are thrown from the very same cliff with the very same height, it means that if rock A travels about 2 meters from the cliff up to the ground, the second rock will also travel the very same height. That is what is common. So if we can use the information of rock 1 and calculate the displacement, we can be able to use the very same equation to calculate the initial velocity with the calculated displacement. So let us do that. Let's say we have rock 1. We are going to use this equation. So we are looking for the displacement, the height of the cliff. Initial velocity was dropped, so we have 0. Time it takes is 3.00 plus half. We have 9.8. We have 3.00 squared. So we know that this will result into 0. So our displacement is 44.1 meters. That is the height of the cliff. So we have 44.1 meters. So with this information, we can go ahead and calculate for rock 2. So we can use the very same equation. The displacement is 44.1. We are looking for the initial velocity. Time it takes is 2.00 plus half. We have 9.8. 2.00 squared. So when you quickly solve for initial velocity, we have 2.00 initial velocity, and then when you punch this on the calculator, we have 19.6. Then we transpose the 19.6 to the other side, we have 2.00. V initial is equals to 44.1 minus 19.6. We divide both sides by 2.00. Then we can see that this will result into 1 multiplied by V initial, it's V initial. So we have V initial, it's equals to 12.25 meters per second. If we round off to 1 decimal place, we are going to have 12.25 meters, it's 12.3 meters per second. It will be downwards, because remember, velocity is a vector, it has magnitude and direction. So I hope you can see how we calculated this. It is very simple. That's it for this lesson video. This is Formula SJ. Thank you very much.